Welcome to StudyOrgo's edition of the explanation of the Oxymercuration-Demercuration reaction mechanism. In this reaction, an alkene is reacted with mercuric acetate dissolved in water and later worked up with sodium borohydride, resulting in the formation of an alcohol. This reaction results in the hydration of the alkene by essentially adding a water molecule across the double bond. Let's take a look at the reaction mechanism. To start the mechanism, mercuric acetate is attacked by the electron-rich alkene to form the first addition. This results in a new carbon-mercury bond that leaves behind a carbocation. Remember the rules for carbocation stability. Because of the inductive effects of carbon-carbon bonds, the more substituted carbon center will have the most stable carbocation. However, the most important resonance structure for drawing this mechanism on the exam is the formation of the mercurium ion intermediate, which results from mercury making a second bond to the carbocation carbon center, resulting in an intermediate that has two bonds to the mercury. This places the positive charge on the mercury ion, which is better able to coordinate the positive charge. However, attack by the weak nucleophile water will result in formation of a new carbon-oxygen bond and breaking of one of the mercury-carbon bonds, resulting in the carbon-mercury intermediate. Deprotonation of the hydronium ion and stabilization of the hydronium ion intermediate leads to the first intermediate in the product. Formation of the carbon-oxygen bond on the most substituted position is known as Markovnikov regioselectivity. Finally, to neutralize the carbon-mercury intermediate, a strong reducing agent, sodium borohydride, will donate a hydride anion, attacking the carbon-mercury center and displacing the mercury to form the final alcohol product. Here at StudyOrgo, we like to give you the tips and tricks to help you prepare for getting ready for the exam. The overall big picture of this oxymercuration-demercuration reaction is transformation of an alkene into an alcohol. The regioselectivity for this reaction is said to be Markovnikov, which means that the alcohol will be placed on the most substituted carbon. This is because the carbocation intermediate will be most stabilized on the more substituted carbon. The reaction process is also said to occur in an anti-addition reaction. This means that the hydride proton and the OH from the water molecule are on opposite sides of the double bond plane. Make sure to include the mercurium ion intermediate in the mechanism, as this is the most stable intermediate and allows the reaction to proceed. Although not in the name, this is an example of a hydration reaction because overall a molecule of water has been added across the double bond. But there are two types of hydration reactions in organic chemistry. The oxymercuration-demercuration, which has a regioselectivity of Markovnikov, meaning the OH is on the more substituted carbon, and also hydroboration oxidation, which is said to occur in anti-Markovnikov regioselectivity. This means that the OH is on the less substituted carbon across the double bond. These two reactions will result in different types of alcohols from exactly the same reactant. So it is important to choose the correct reagent to get the desired product. That concludes our explanation of the oxymercuration-demercuration reaction mechanism. We thank you for watching.